Hello and welcome to this edition of Marvell's Follow the Wire video series. In this video, we're going to discuss the value that I/O devices that support RDMA, or Remote Direct Memory Access, can deliver in enterprise data center for HPE customers. First, let's review what RDMA is and why it's starting to show up in conversations with enterprise customers. RDMA technology by itself is not new. It's been used in high-performance computing space for over a decade, and it reduces the I/O latency by allowing the I/O device to talk directly to the memory and bypass the software kernel. In a normal TCP/IP stack on the left, each I/O transaction is processed by the adapter, then flows through the kernel software and the OS, and then to the application. Now, when an RDMA-enabled I/O device is utilized, the I/O transactions are still processed in the adapter, but the OS kernel is bypassed and the I/O adapter accesses the application memory directly. Now, this greatly speeds up the I/O communication and reduces the workload on the host CPU. Because Ethernet is the most common transport for networking in the data center, and new technologies and applications are becoming more latency sensitive, RDMA over Ethernet networks is slowly finding its way into the enterprise data center near you. Now, as we discussed in our iWARP or RoCE RDMA, the choice is yours video, there are two different RDMA protocols to choose from, and they're not interoperable. Both provide lower latency than standard Ethernet, and both reduce the CPU utilization required for those I/O transactions. As we discussed in another video, just to review quickly, RDMA over Converged Ethernet is the predominant RDMA protocol that's used today primarily in the high-performance compute and cloud spaces. The key benefit to RoCE is that it provides the lowest latency at the adapter, and the challenge is that the complexity of the fabric required to deploy RoCE RDMA. The other RDMA protocol is iWARP. iWARP's advantage is that it runs on standard TCP/IP stack, and that makes it really easy to deploy. From a latency perspective, it's 6 to 10 microseconds, which is a little bit higher than RoCE, but well below that of a standard NIC. And the challenge with iWARP is that it has not been as widely embraced by operating system and storage vendors, but that's changing with VMware support expected in the very near future. One key feature that Marvell FastLinQ adapters for HPE have is that they support universal RDMA. They support both RoCE and iWARP on the same adapter. And this provides customers with more choice than any other RDMA-enabled offerings. If we look at the practical difference between iWARP and RoCE in terms of what an administrator needs to do, we can see here that in HPE's Windows Server 2019 Azure Stack HCI implementation guide, the contrast and simplicity between iWARP and RoCE becomes pretty evident. iWARP runs on the existing TCP/IP stack, as I said, and only requires 2 clicks to enable in this solution. RoCE, on the other hand, requires network infrastructure, i.e. switches, that support lossless Ethernet. That means data center bridging, priority flow control, and some other requirements. And it requires significantly more steps to just get enabled. Configuration isn't just required in the adapter, but every switch port as well. Now, I've mentioned about RDMA reducing CPU utilization a couple of times already, and this slide shows in real terms what I'm talking about. Here we see the effect for live migration of multiple VMs from one physical server to the other using, in this case, Microsoft Server 2016 Hyper-V. We are also using a 25 gigabit Ethernet network connection. Now, in our internal tests in our labs, we migrated 2, 4, and 6 VMs between the servers and measured the amount of CPU resources required and the transfer rate that we achieved. Now, as you can see, CPU utilization, which is represented by the dark shaded area, was between 10 and 15%, and the transfer rate topped out at only around 8 or 9 gigabits per second, hardly close to the 25 gigabit bandwidth that's available. Then we enabled RDMA, and in this case it was iWARP. Notice that the CPU utilization dropped to under 5% for the most part, and the transfer rate hit the 25 gigabit maximum. The effect of this is that CPU resources are now available for other tasks, and the actual transfer of the virtual machines took half the time when compared to the non-RDMA environment. Typically, when administrators migrate VMs, it's because the system they're on is running slow, or they need to balance resources, or there's some kind of maintenance going on. In either case, the impact to CPU resources and the time it takes to get the job done are both critical. With an RDMA-enabled network, the impact is considerable in terms of reducing the time it takes to complete the migration and limiting the impact on the system resources. What system administrator wouldn't want such tasks to complete in half the time? And the $70 price tag, which is the delta between a standard 10 gig NIC and a 10 and 25 gig RDMA-enabled NIC, looks pretty reasonable at this point. Now let's look at using RDMA in software-defined or hyper-converged infrastructure solutions, or HCI solutions. HPE adapters from Marvell can be used in both VMware vSAN and Microsoft Azure Stack HCI implementations. The key advantages to the FastLinQ adapters are the variety of offloads we have to reduce CPU utilization and improve that VM scalability, of course, but also improve performance with RDMA to support low latency communication between servers and storage. In the software-defined solutions, VMware utilizes the VMware file system, or VMFS, to move data between servers, and Microsoft Azure Stack HCI uses SMB Direct to move the data. Looking closer at VMware and vSAN, they'll initially support RoCE RDMA, and there will be support for iWARP sometime in the very near future. For VMware ESXi, RDMA can be used for east-west traffic between the servers, and it can also be used to support north-south traffic when connected to shared storage that supports NVMe over fabrics. Now, this can work well for future solutions like HPE's DHCi with Nimble today, once that storage platform can support a native NVMe over fabric communications. We shared this slide in our prior RDMA video, but I think it's worth reviewing again. RDMA is becoming more prevalent and in some cases required with popular enterprise applications and operating systems. We just discussed how RDMA can be used in hyperconverged and software-defined solutions, and it's widely used in cloud applications as well. More and more enterprise customers will benefit as well from RDMA with big data applications like Hadoop and SAP HANA. And you'll also see customers benefit from RDMA with SQL or Oracle database applications or for any latency sensitive application. And finally, customers who are considering that NVMe type storage arrays may need to deploy NVMe over Ethernet fabrics, and to do this, RDMA is a hard, fast requirement. To support RDMA, you'll want to make sure the switches you're recommending are right for the job. So we put this list together to show you just some of the switches from the HPE Aruba networking group that support both iWARP and RoCE RDMA. Note, always refer to the HPE quick specs for networking features supported by individual switch models. And here's a similar list for the fabric modules for those of you deploying HPE Synergy servers. For Ethernet adapters, this lists the 10, 20, and 25 gigabit Ethernet products with RDMA technology from Marvell for HPE Gen 10 rack and tower servers. All the adapters are RDMA enabled for Gen 10 servers, and they're also listed as supported by both VMware and Microsoft for their vSAN and Azure Stack HCI solutions respectively. We offer a variety of connection types with 10 G base T, 10 gig SFP+, and of course 10 25 gig adapter option. Here's the portfolio list for the Marvell FastLinQ 10 and 25 gigabit Ethernet products for HPE Gen 10 Plus, ProLiant, and Apollo rack and tower servers. Again, all of these are RDMA enabled and listed in the VMware and Microsoft HCL listings. For Gen 10 Plus, we offer two form factors, PCIe stand-up and also what's called OCP 3.0 or Open Compute Platform 3.0 form factors. We have 10 G base T, 10 gig SFP+, and 10 and 25 gigabit bandwidth connections. Note that we also have a quad port 10 gigabit Ethernet SFP+ offering for these servers as well. So let's summarize. RDMA is going to be required in the data center soon. You can future-proof the Gen 10 and Gen 10 Plus servers that you provide to customers by using 10 gigabit or 1025 gigabit adapters that support RDMA protocols. And with Marvell FastLinQ as your adapter of choice, your customers get universal RDMA capability, providing more flexibility and support for both Rocky and iWARP RDMA, depending on how they want to deploy their RDMA-enabled solutions. So here's the call to action. Follow that wire. Make sure you're discussing the need for RDMA with all of your customers when you're talking about any kind of server storage opportunity. If you need help, you know where to find us. Join our Yammer group and communicate with our I/O experts on the HPE team here at Marvell, as well as with colleagues out there in the field. Stay up to date by signing up for our communications. Of course, bookmark our microsite and join the Follow the Wire Rewards program. That's it for this Follow the Wire video. I hope you found the information useful. Please bookmark our microsite here. If you need to get a hold of us, you can use the email shown here. Thanks for your time and attention, and I'll talk to you on our next Follow the Wire video. Have yourself a wonderful rest of the day.